I'll head into this. This is, I can say, this is part of a talk with the fiasco that was the last summit. I was going to do some of this as part of the kernel hands-on lab, which hopefully we can do again at some point. I just didn't have the cycles. We didn't have the cycles to arrange for it this time. But anyway, there was part of this that you'll see I included some reference slides at the end that it's based on some of the information I was going to share in that as well. So I wanted to reuse and try to leverage a little bit of that. So the whole point of this is, we've had, I guess it seems more frequent recently, people popping in and out, trying to figure out why things are like they are and how things work and this and that and what they can do with it. So I have a little bit of explanations and some details around some of the workflows and how and why the reference kernel, looks like it does. And that might hopefully, I think, when Trevor looked at it, he found some stuff he hadn't heard before, which was good because he's actually done the kernel hands-on lab. And so I'm hoping can share a little bit of information. The intent is not to change anybody's workflow or fully explain my workflow, because if you've ever worked with kernel people, a good first rule or first contact rule is don't ask them to change their workflow. So I'm not asking anybody to change their workflow, and I'm not asking for anybody to change my workflow is the summary of this. But what I'm going to cover is, like I said, the why, what, the who. I was trying to do the who, what, why, when, where, but the who is pretty obvious. And so we just went with a short version of it. And the when and the where, it's I just wanted to try to describe, what actually goes on behind the scenes when we're maintaining these references, to give an example, a better feeling for how much work it is to actually keep the master branch working and chugging along at a cadence with new kernels. It's sort of the classic problem where it's easy to get your board booting or a board booting. We used to hit this with preempt RT. Yeah, it's great. You integrated and you booted your board, but have you actually stress tested to make sure it actually is real time, right? So it's easy to get a single board or maintain a few boards, but you'll see in some of my slides, it's to understand how there's so many different architectures, boards, reference boards, and versions that are active sort of at any one given time. And then I threw out a couple of quick sample recipes to show the 4 and 5 liners, because we've had people asking this recently. So I took the 10 minutes and did a couple of sample recipes for different kernel versions and things as well. And then the reference is really that configuration option analysis and debugging that we probably won't even get to them. I'm putting them there for people to maybe, if anybody ever goes to look at the slides, they can use them as a reference. All right, the why, just like I need to move this little breakout thing. Actually, I think I can minimize it. There we go. Why? And it didn't page down. Oh, there we go. I should have just made this slide say why not and moved on, but I won't. I didn't. So, Linux-yocto, the purpose, what it's supposed to do and why it's been around for 10 years now. It is sort of this multi-architecture maintained reference kernel. It's not tied to a board. It's not tied to a vendor. It's not, it's sort of completely independent of all those things. It is there to test users tightly coupled and the general user space kernel stacks, because we use it to drive the Linux libc headers as well. It is identical to mainline Linux kernel in many branches, and I have some details about that and future slides. It is what does actually help. You'll see me sending patches out as I go through the dev kernel flow, where it's sort of the tightly coupled kernel package. There's ones that always break every time I upgrade. So, we produce a new libc headers, perf, LTTNG, system tap. There's a bunch of ones that have quite a few couplings to the kernel, and so that's what we use to sort of support and drive those type of packages. It's a way to help with some workflow changes, improvements, packaging, if you will, in the core. It does provide a sort of cadence and inertia about, the same way that the Yocto project LTS provides that. We like to have, rather than anybody who's dealt with vendor kernels or other kernels, you would pretty much have somebody using every single kernel version from every single tree with every single random stable release that they don't want to move off of if we didn't have a sort of a predictable cadence and inertia. And we documented this on the wiki 10 years ago, and it's still roughly the same for the cadence that it goes through. So we have predictable upgrades and predictable versions to try to consolidate some of our testing around. So that's so we can get that collaboration and we can leverage collective testing on the various parts of the ecosystem. You know, um, Off and on, it does support BSPs and assist upstreaming, meaning we carry, and that's why it's branched, we carry either BSP ports or SOC branches as sort of a sharing point of some of the kernel code that's maybe not quite ready to go all the way to the mainline kernel yet, or it's a little bit faster. Let's just say the acceptance criteria are not as rigorous as the mainline kernel. And it's what drives the kernel configuration, metadata, and tooling, which can be more important or useful than you may think. And in fact, the merge config.sh that you see in the mainline kernel came from what we do. I was in the meetings where we took how we were managing the fragments, and that's where that came from. So that's what it is, and that's the purpose. What it is not. It is not a fork. It is not to replace, fork, or otherwise supersede the mainline kernel. Repeat after me. It does not replace, fork, or otherwise supersede the mainline kernel. It's there because, well, I'll get into the details of why it is like it is, but let's just say you can't have 2,500 patches at any given time on top of the kernel and be cloning directly from kernel.org and not go insane. Been there, done that. And this is what you get. An insane guy giving you a presentation as the last one for the conference. It is not must use. All of the extended checking and different things that we added for quote unquote kernel Yocto, they are separate from the core kernel support. So you don't have to use it. It's fully opt-in. It's just there as the reference and off to the side. It's intended to support, it's not intended to support all BSPs and use cases. Vendor kernels, OSVs, you can use some of the tooling, none of the tooling, all of it, whatever you want. It's not intended to solve everybody's problem all the time. It is not production complete, but it is definitely production ready with the processes and the workflows that go through. It just may not have the level of testing on a particular platform or board that you would want to consider it production ready. So that's the why and the what. So there's these things that we use in the background, called the kernel tools. It's the kernel tools native recipe. It's got its own little repository hosted on git.yoctoproject.org. And those tools were sort of developed over 10 years, preceding the 10 years that a lot of the stuff has been in Yocto. So let's just say from 2005 to 2015, for 10 years of maintaining a distribution kernel for an embedded Linux vendor. You get questions, and we had something on the mailing list recently. It's like, yes, almost everything has been tried. It started with Quilt and directories full of patches like everybody else has, and then I used something called Gilt, which was a Git wrapper around Quilt, and that failed spectacularly. There was revisions of the tools that could do patch detection and resume patch queues, and there's almost everything. And yes, we're aware of Git rebase and all of the new tools and everything that you can do, but the big thing is Git is the right tool to manage this type of thing. And so it embraces and uses Git and the capabilities, and that hasn't hasn't really broken severely in say 7 years. So and it's like, no, we can't equally maintain it with a directory full of patches, because I've been there, done that at 2 a.m. after a feature freeze, trying to make sure that when somebody did preempt RT and this board and that YAFFS2 feature, that all of a sudden the patches don't apply because they can't possibly stack in that order. And that's the kind of things that we support. So you'll spend your life fixing patch fuzz and patch failures, but if you maintain a branched kernel repository, you can survive this chaos. And so what the processes and the tools do is they sort of scale at any time in Yocto. I'm supporting roughly 6 different major kernel versions, 6 architectures, 14 reference boards in OE core, Meta Yocto, BSP alone, and 3 different kernel types, stacked with 30 plus invasive and non-invasive features. And by invasive, I mean something like preempt RT or AOFS. And these have come and gone over time. There's actually fewer now because everybody's getting good at getting better at mainlining their features. And there's backported patches, there's CVEs, there's fixes that are specific to what we do. So there's hundreds up to thousands of changes at any one given time. And like I said before, those may or may not conflict, and they may or may not be used in many different combinations. So in order to scale to that, that's sort of what this is. So when somebody looks at it and they're like, yeah, man, I just want to put one patch on a kernel tree. Why is this thing doing all of this? It's like, yeah, well, it can do that, but it has to make a few compromises to be able to maybe scale to something like this at the same time. The tools actually serve many different purposes. So exactly the same tools are what I use for the day-to-day management of the kernel. They do the kernel configuration audit and reporting. They have, OE core build support, what you see in the kernel Yocto BB class. What they do, they support this kernel Yocto quote unquote style build. They can do a standard core kernel style, or they could say work with your tar gzip korg thing and non-git patches. They can handle those different types of builds. A bit in reference to what John and I were talking about. In fact, these tools, and they were initially created to be able to do kernel sanity builds and support it, outside of open embedded build support. So they still are used in various places without being invoked and wrapped by the open embedded build. And they can do a full tree reconstruction and configuration maintenance. And what that means is you can take a stock Linux kernel.org repository, run the tools against it like I do every single dev kernel, and it recreates the branches, the patches, and puts them on the tip, and it's sort of clean on top of it. So at any point, we can do that. And you may ask why, and I'm telling you, you can't merge preempt RT with 5.2 and then merge 5.4, 5.8, 5.10, different versions of RT into a single Git branch and actually have a history that is vaguely maintainable and supportable. Again, you can do anything with enough effort, but I've been there and done that, and it doesn't work. So what we do is we make sure any single version is fast forward and not rebased, but we create new version branches, or in the past, separate repositories for different kernel versions to make sure that you can at least detangle, drop a feature, merge a new one, do an update whenever we fork a new reference kernel. The repositories that are involved in this, there's the branched and version kernel source trees, which is Linuxyocto and Linuxyoctodev. In theory, they could be one, or we could split them apart. It doesn't really matter. The content is actually the same. And then there's the kernel configuration and metadata, which is this Yocto kernel cache. And what that is, it's tracking the patches themselves that have been applied to the tree, as well as the kernel configuration over time. So at any point, if you wonder what is applied to a branch and you can't dig it out of the Git history because it's munged in with Linux next merges and AUFS and preempt-RT, this actual other repository tracks the patches and what happens to them over time. So it's not mixed in with the kernel history. So it's completely clean from that point of view. I didn't ask. I'm probably sure nobody has any questions, but if there is, please do interrupt me.
So far, so good.
All right. So the current tools in the build, this is, these are the questions. So there's a few little phases, and this is actually what's changed the most over time. They used to be actually way complex due to their history, and they used to break a lot because they did crazy things like look at the patch queue, look at the first patch, try to figure out where in Git history if it was or wasn't applied, and then it could literally resume a patch queue in the middle by detecting an endpoint. But if somebody used two short logs that were the same, or we had a conflicting MD5 sum, it would resume in the wrong place and you would get terrible patch failures, and it was absolutely horrible to debug. So over time, I've simplified what it does. So it has a preparation phase, and that's this do kernel metadata. And so that just takes a look at what has come in on the source URI, the standard source URI. There's the variable kernel features, and it looks for configuration fragments, which are .cfe, CFG. It looks for patches. It can take a kernel metadata repository, or it can look for these .scc files, which are literally combinations of .cfg and .patches in the same thing. So it takes all of those. It runs a couple of tools out of the current tools repository, which generates what patches, what branches, and what configuration needs to be done. So it tells us where to start building, which is the BSP entry point. It creates a file called config-q, which is all of the fragments that are going to be merged together to create the .config. It creates a patch queue, which is literally what you'd expect, what patches to apply on the end. And it can actually still generate a little used feature of a merge queue where you can actually do git merges at the build time. If you have a branched repository, you can sometimes, some people want to do this. So it generates that as well. It then has its own, it then moves into application. It has its own sort of do patch and do kernel config me. The name's a bit old. It made sense when there was other phases. So what happens here is it has a little tool that knows how to wrap git am and deal with the patches in a way that failures, they don't even have to be proper. We run in with preempt-RT and some of the other patches, they didn't always have proper git headers, so they would fail git am. So this knows how to wrap those and make sure they can be applied. And if they fail, you can resolve them and then re-export the patch. So it's a shell script around that. So it takes the config queue and just applies it to the branch. It uses Git directly if you're doing merges, and of course configuration. It was a little bit hidden before, but it's pulled right out. You can see it in the BB classes. It's just calling merge config.sh, which is right from the mainline kernel, to actually merge the configuration fragments out of the config.q and produce the .config. And then once all that's done, you do your build, everything works. It then does an audit, and that's something that I have rewritten in the last year into Python, which is good. And it is the one that does, it's called symbol Y. And even though it's annoying when it catches even me, it is trying to help us keep us all from hurting ourselves, and that it will tell you if you had duplicated options, if you had an option that didn't show up in the tree, if you have an option that you wanted to be a module and it showed up as built in, or vice versa, or it didn't show up in the final config, because these are the sort of things that get you a broken boot in a broken BSP, and it's trying to help you. And it's something that I use to keep the kernel configuration metadata clean over time. And in fact, even in the mainline kernel, you'll see some of the def configs get missed and they reference invalid configs, or their configs don't make it into the final output. And while usually not fatal, it is something you might want to be warned about. And it has various levels of verbosity, so you can actually ignore things that you don't want to see all the time.
So Richard Purdy wants to know, are there plans to add automated test? Smiley face emoji.
For which part? Yes, maybe.
And
Um,
Tim wants to know if we should partner with Kernel CI for tests.
we should. They've at some points I do get builds. The tree has been watched in the past, and I would get build failures from them on some of my branches, and it was a little bit annoying because until the way ours works, until I sometimes push changes to the Linux-Yocto repository, and until I've sent the source rev bumps to the list, it's not officially released. So I've had build errors reported to me before I've actually released my kernel. So I haven't even got a chance to do my own fix-up patch on the end. But yeah, there is things that we could do there to get even more coverage. And I
Uh,
want to do my GitLab CI for Dummies build on it as well as a test.
nice. With respect to the symbol Y and all that extra checking you added recently, is there a way to promote it to fatal errors instead of just warnings?
Yes, somebody asked me to do that, and I'm positive I wrote a variable that lets them be fatal, but I don't know off the top of my head. So it's not out of the question. It was asked, and yeah, there's a way that we can make it error.
Great.
All right. Yep. Okay. Good. And so I don't 344. I'll start moving a bit faster. Um, I just wanted to point out, and this is maybe of interest. Linuxyocto. There's the Linuxyocto. Oh my goodness, Linuxyoctodev repository, and it tracks almost every kernel.org version. So there's different branches. You can see them in there. The in progress active ones are standard star. Archived ones that we have done a Linux-Yoctodev cycle on have the version just like Linux-Yocto, so v5.10 standard star. Um, I do regenerate standard star when we move to a new version, so they may rebase. And I note that we could either fold it into Linux-Yocto or not because the repository is getting a little bit big. So um, if you're looking for the kernel, for instance, Linux-Yoctodev is building 5.13 right now. I haven't officially updated it, but that's where it is. Linux-Yocto is our single repository that tracks all released and maintained versions. So the branching is that master of that is the unmodified tracking branch for the tip of Linus's tree when Bruce remembers to update it, and that should be automated. Um, the V version / base is an unmodified upstream release that tracks stable. So v5.10 base would be the latest v5.10 stable from Greg KH with no changes, none of my stuff in it. Everything that we merge for our own purposes is under standard base, not base. So that's small, always specific changes, perf build fixes, boot quirks, things like that. And then you'll see we have some SOCs that we maintain, and they're under standard / BSP or some other topic branch names. And that's because these changes are either touching files they shouldn't, or they're large and we don't want to deal with the failures on them. So they are given their own branch. But whenever you'll see, whenever I do a standard up, like a dash stable update, every single one of these branches gets the change, and I get to deal with the breakage and the BSPs and the SOCs to try to make them merge. And if you watch Linux-Yocto, you'll see where I get it wrong sometimes, and I get fix up patches to those. So this is, yeah. So this is basically what I said before. OECore master has the active release recipes, which would be a dev one, LTS, and some sort of latest one. And that's only when LTS does not equal latest. So at one point, we just had a newer one in 5.10, for example. It also has RT and tiny variants for the same version as those, although unless upstream RT has done a release, if they haven't done a release on that version, well, we're not porting preempt RT. So the branches are there, but it's only configuration for real-time kernels that would be there at that point. And you can build against any unreleased version. It's simple. And I wrote an example with a v5.7 kernel, which we never ever released as an official reference kernel as part of the release process. There, I covered that faster. I'm almost back on where I thought I would be. So this is the when where, a week in the life of Bruce sitting here trying to merge and maintain these kernels. So
Bill is curious about the tiny variant.
it now it's mainly configuration. It used to actually have the tiny patches that were, trying to save a few kilobytes here and there. But since they've been dead for a while and or merged into the mainline kernel, it is mainly just coupled with the more minimal C libraries and a set of configuration changes. Like it doesn't all no config to start and then adds configs instead of doing a def config and then adds configs, for example. So
Is there any relationship to the kernel tinification project from years back, or is that
yeah,
something?
it is. Yeah, it is. That's sort of, we used to have a big queue of patches in there, but not for a while now. But we reserve, oh, sorry, I'm yelling. We reserve the right to, I've kept the branches around because there is config changes that are triggered off of it. And we could always merge something in there that we want to keep away from the rest of the builds that does something to make it smaller that might be destructive to other features. So, as part of the maintenance, what happens sort of daily as required. We get changes on the Linux-Yocto mailing list. People will send me either pull requests or I see things on LKML. Somebody asked me to cherry pick a patch on IRC, something like that. That's sort of where the inputs come from for this. And whether they be normal bug fixes, say Bruce broke a merge, or there's a different bug fix or something that somebody cares about that hasn't popped up on my radar. They might be CVE or standard. I get SOC, BSP merge updates, new features, config tweaks. That's the sort of things that come in on a daily basis. And, the testing for those is local, meaning I build it. And then when I'm batching it up for Richard, I'll do an auto builder run unless it's quite small and I'm sure that my local build is enough. Again, this is where we want to get that plus GitLab, CI for dummies in there so I can maybe do that a little bit more easily. Weekly and sometimes multiple times a week, if somebody wanders through and tells me there's a priority fix in one of them, I'll do for the current release, I will do the dash stable merges. Usually on Monday morning, I'll bring in the Greg's latest stables to right now 5.10, 5.4. I'll test them locally and on the auto builder and send them out. Bi-weekly or roughly, that none of this is written in stone. I will actually do stable merges to EOL. Well, not fully EOL, but older releases. So I go back and I've done 4.19, 4.4, different kernel versions that are still getting upstream stables. I will go through and unleash my stable scripts on those to do updates. And that testing is just local because we don't really have an active release for that. Monthly, that's what I meant. I do older stable merges, and honestly, they're build test only. Once I'm updating 4.19, for example, I'll make sure that everything applied cleanly, but it's a build test. There's not a lot of booting that goes on for those. Bi-monthly Linuxyoctodev generation and bring up happens, and that obviously follows the kernel.org release cycle, right? With the 2-week merge windows, 6 to 8 weeks of stabilization. And every time one of those happens, I do a new Linuxyoctodev. And at that point, I do the feature merges. I make sure AUFS has a new version, is preempt RT available. Does YAFFS2 merge? And then I do basic and sort of core testing on it. Make sure perf builds, make sure the things that we know we test works. About quarterly is when I generate the new sort of named and version Linuxyocto recipes for release. And I tip my hand that I can generate them fairly quickly because I sent Richard a 5.12 one without much effort to try to narrow down a bug just recently. And so that's just us moving into Linuxyocto, creating that V whatever branch, and that's where I do the full configuration audit and support matrix testing. So it's sort of leveraged off of the basic testing, and it's more. And then periodic, if somebody asks me to merge a fix into some unsupported kernel that I'm not normally looking at, I can always take a patch and merge it because it's not a whole lot of effort. I know I'm technically out of time, but I will I just put these in here to show somebody, how some of it's a little bit old school, and there's some scripts that do a whole bunch of stuff on my behalf, and they're automated. So, if I get a bug fix or a CVE, I go into my local repository, I check out the proper branch, I get AM to see the M box that I was sent, and then this little script that I wrote is a way to automatically take a branch and merge it out to some great other set of branches. So you merge the standard base out to all of its children branches. So every BSP that I mentioned, they all get the fix. And then that tracking repository I talked about, I commit the patch there. If it's not part of stable or it's not something we'll pick up later, that way it will be there when I do the next kernel generation. And then I have a script that knows how to go through and generate um, and update the recipes with the source rev bumps and write a commit message for me. And then I push it. And then, like I said, after this, I release the fix via pull request to OE core. But until I've done that part, I don't consider it release for anybody that's that's building my changes. Stable merge is similar, but I have different scripts to do that. I have a way that can automatically look at the stable tree, find the current tag, increment it by one, fetch Greg's tag, commit it, and then merge it out to all of the branches. Um, and again, it looks at, you see right here, I put in here, potentially spend hours fixing merge conflicts, etc. I spent 3 hours last week trying to fix a conflict with preempt RT and archarm kernel start.s or head.s. Anyway, there was a non-trivial merge. So it looks easy with the scripts, but on an easy dash stable, it does this. We then commit the update to the kernel cache, and I have a release script that automatically bumps the Linux version, and then again the same process, and I send it out. And if anybody wants to see the scripts, they're all local and they're all nasty, but I'm happy to share them. There's nothing secret or proprietary about them. And I won't go through this in the spirit of time. This is just what I do. If you wonder again, hey, what is Linux-yocto for and what does it do? And this is what I do whenever time I'm releasing a kernel. These are the different things. These are the tools that I was mentioning can take a clean tree, run through and generate me all the branches with all the changes and all the metadata available for either local build or pushing to the repository so we can do automated building. It's at that time I refresh patches for fuzz, drop obsolete patches, import new features, and that sort of thing. And it keeps going. You see, right? This is all right. This update the kernel configuration data. We synchronize Linux libc headers, create the version recipe, build test the configuration, audit cleanup, boot feature testing, push the branches to Linux Yocto, and then profit and all your fame and fortune for your maintenance trouble. And then, of course, after that, we then have a cycle of going through and updating the preferred versions for the reference BSPs and bumping QEMU and getting luckily the Wind River guys help with updating the reference hardware BSPs. Otherwise, I would be in big trouble for time. All right. I actually didn't plan on presenting this because I know I'm almost out of time and I'm over time. But so if anybody wants to go look and somebody says, hey, I just want a recipe to do this, I did some reference recipes, and this is the entirety of the recipe with comments. Is I could have fit it on one slide that you can build v5.7 either with a def config or with Linux-yocto kernel fragments. So I threw in some examples of these just so if anybody wants them as a reference, that it's, and then here's a pure kernel.org one for 5.13 RC2, which I did actually boot test in preparation for this. So this is how it does fit on, there you go. This is using the tools. It fits on one large font slide to pick your random version. So when anybody says it's hard, it's not supposed to be. It's just maybe we need to find a place to document these better because it really should just work. And that's it. And I know we're over time, so I probably ran people out of time for questions, and that was totally on purpose.
No, that's fine. As far as I'm concerned, you are the last talk for the day, so I'm not too upset about that. There was a question from Alejandro. which was interesting because he was wondering, okay, if you do a kernel build and you get those warnings to say something you were trying to include and your config didn't make it and stuff like that, what could you do? Um, if it's okay with you, if because I know that you have supplemental slides where you actually go through that and you show sort of the tricks, because you have tools that will help you analyze what went wrong and why something wasn't included. And so because it was asked, if you're okay with spending a couple minutes on that, I'm
Let
okay
me
with it.
jump through them. Yeah, let me just jump through them quickly because it's good to advertise, because the rewrite to symbol Y was actually significant. The old one was very hard to maintain, and it's using underneath kconfig lib. I can't take the credit. Although we did fix it for 5.13, we may have the only fix on the planet right now for that. Who knows? Because I have to check with the GitHub to see if I can send it up. But um, and I think Trevor will probably chuckle at this line. So the commonly asked question that we get popped up, it says the kernel configuration phase ignores my option. And the truth is that I totally wrote something that does a random, whether it's going to ignore your option or not. So that is what it does. And when your option gets ignored, you just got unlucky. So just build it again. It might pick it up the second time through. But the reality is the option is likely missing a dependency. It's not reachable, or it's disabled by another fragment. And that leads into that question. Um, so before, we used to have this manual inspection of merge config and audit logs and other tricks. You'd make menu config and look around. But I did rewrite the tools for GatesGarth, and so there's more information that's available. There's more flexibility to ignore options that are not a problem, so you can silence them once you've done the audit. Um, and you can do a full config or option-specific analysis. So I actually, every Linux-yocto or kernel-yocto build, if you will, does do a kernel config check run. And there's actually, I wrote a task config analysis that you can actually specify your option in your local.conf, and it will run the analysis on that and tell you in detail. We're going to skip this. This is audit levels, different audit levels. So you could run this config analysis on Linux-yocto, and it actually dumps out details in a couple of text files to tell you sort of, what was wrong. And what's in there is, here's an example. It tells you, you set config local version was set, but it wasn't assignable. So check your thing, right? So the symbol blame in this case was, we got a few different things that were wrong. Or this is a better one. Config IPNF target masquerade last val was yes, meaning the the dot config here. I invert this in my head all the time, so I imagine everybody else does as well. The dot config was module, but your last fragment wanted it to be yes. And that could be a problem if you're using it as boot support, if it's a module and you're not doing module loading. So it's telling you that the last value did not match what was in the config. And in this case, it is telling you that it is a Y because its dependencies are all built in, or it's got it's got some of its dependencies are modules right here. IPNF tables is equal to M, and that's why it chained down. To be a module. So it's trying to tell you, it'll tell you what the parents are, what the dependencies are, whether it was selected by something else, and that will tell you how it ended up at that value. And there's different ways to resolve it. You may have to chase down all of those other dependent or selecting symbols and change them if you really want it to be, if you really want it to be a module or built in, you might have to, it can actually chain out to quite a few different options. Or you can decide that's good enough, and then you can mask, you can inhibit the warning. But the point is, these tools based on kconfig lib can go in and it looks around the active configuration and will tell you all kinds of things about what the symbols are doing. Because bottom line is, you can try to make something a module, but if something else in the kernel configuration does a select Y on it, you'll never be able to make it a module. And that's what this will tell you. So you have to be aware of that. Just because a fragment sets a value doesn't mean it gets to be the value.
Cool. Yeah, I think that'll be very helpful. Um, Andre from Meta Raspberry Pi is asking, basically is looking for a use case where he can say, apply this config no matter what the kernel provider. He's asking if there's a way to apply configuration over BSP kernels and providers or other versions.
Like
Can we
without
use?
adding an inherent kernel yocto, for example?
He
Yeah.
doesn't specify. Oh, okay, all right.
Hi, Bruce. Yeah, basically looking for something that would be agnostic to any provider that you have without writing BB appends or doing some sort of BB class automatic inheritance that checks for virtual provider and does any other hacks there.
I can send you a patch to try. I have one in my local tree. In fact, I run all the time with one that does that. I just have never been willing to take the pain of the bike shedding on the mailing list probably to um, everybody's view on kernel configuration merging. Always seems so painful, so I haven't sent it. But if you're willing to try it, I can send it to you, and maybe that'll motivate me to send it up. Basically, I've moved some of the merge config logic into kernel BB class and made it optional. It gets enabled automatically if it detects a config, a .cfg or .sec in the source URI. It gets turned on, and my Linux-yocto local builds all use that to do the merging.
That sounds amazing. I'll definitely be up for that.
All right. So yeah, that patch exists, and I build with it every day, so I can send it to you.
Brilliant. Cheers.